Hello, everyone, and welcome back to my channel, Ozzy's Young Learning Emporium, or also known as AYLE. Um, in this video, we're going to be exploring multiplication at a year 7, year 8 level, and it is going to be including stuff like long multiplication or the multiplication algorithm and multiplying decimals and more about that. So, what is multiplication? Multiplication is a mathematical operation that combines groups of numbers to find their total or product, right? So if we go and remember, if we have two apples and we multiply that by three, so we've got three groups of two apples. That's going to be two, 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 so six apples in total. So three groups of two is going to be six. So this is how I like to look at multiplication. Anyways, let's get started now. So, if we delve into this world of multiplication, as we looked at before, multiplication is basically the operation which combines multiple groups the desired number of times. So, what does that mean? If we take these three circles, so that is a group of three. Okay, and now if we do 3 times 4, that's going to be this group of 3 added to each other 4 times. That's basically multiplication. And we can talk about repeated addition right here because multiplication is the same as repeated addition. So if we have 4 times 4, then that is equal to 4 plus 4 plus 4 plus 4. So we are just adding this 4, so a group of 4 times. So that's going to give us 4 plus 4 plus 4 plus 4. Similarly, with 16 times 5, we've got 5 groups of 16. So we've got these 5 groups of 16. Similarly, we can also write this as 16 groups of 5. So we would have here that is going to be equal to 5 plus 5 plus 5 plus 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that is going to be our repeated addition for this multiplication. Now, in the past, when we looked at multiplication, we used to use our basic knowledge, like we know the 3 times table. So if we've got 3 times 5, boom, we know that 3 times 5 is going to be 15. We don't have to think about it because we've got it memorized. But I'm going to be showing you how, if the number is bigger and you don't know your basic facts for that times table, because you probably would, like 122 times 134, you're not going to know the times table of 134 probably. So we're going to be looking at the long method, which is going to be our multiplication algorithm. But before that, there are a few facts we can look at. These facts will help us do multiplication, such as if we don't know 16 times table, you can easily do 16 times 4. Because if we've got 16 times 4, that's basically equal to 10 times 4. That makes the 10 of the 16, and 6 times 4, because we talked about this. Hey, if we've got 10 groups of 4 and we've got 6 groups of 4, that's going to be 16 groups of 4. So there's no difference. So we can also write it like that, and we can figure it out much more easily, because 10 times 4, boom, we know it's 40, and 6 times 4 is 24. So 40 plus 24 is 64. Also, this is just a very cool fact, just gonna help you do multiplication real quickly. If we've got 10 times any number, that number's decimal would shift once to the right. So it's gonna get bigger, just saying, because when you shift it to the right, you add on a 0. So we've got 10 times 4 is going to be 4, because the decimal was there before, because here this is a decimal. Because this decimal was here, it gets shifted to the right once, and that makes 40. Similarly, if we had 10 times, let's say 2.4. What would happen here is that we know that the decimal is there, but we're just going to shift it once to the right. So we've got 10 times 2. Now that shifts 1 to the right, and that makes 24. So it's not necessarily that when you multiply by 10 you're going to get a 0 at the end, but if with the decimal numbers, but with like normal integers. We're going to get to integers soon, but just so you know, integers is any number from negative infinity to positive infinity, and it is a whole number, no decimals and integers. So if it's a non-decimal number, meaning it does not have a decimal point in the number, it means that it's going to end with a 0 when you multiply by 10. Okay, now we're going to be looking at the long method or the multiplication algorithm. Cool, so let's get started. For the long method algorithm, how can we do this? So if we've got a question like 12 times 334, how will we do that? The easy method is to write it like this. So 334, and 12 on the bottom, and we put a multiplication sign there, and now we're going to, so this might look a bit similar to the addition algorithm, but it's a little bit different. We start from the right, always from the right, so we've got 2 times 4. We look at this number only first. So we multiply this number by all of these numbers one by one. So we've got 2 times 4 is 8. And then 2 times 3 is 6. And then 2 times 3 is 6 again. Now, because we're going to the next number, which is times 10, we're going to put a 0. Because as we talked before, when you multiply a number by 10, you get a 0 at the end, or you get the decimal point shifted to the right. So we're going to put this 0 to indicate that we're going to the next number. So now we've got one. Now we multiply this number by all of these numbers, one by one. So 1 times 4 is 4, 1 times 3 is 3, and 1 times 3 is 3 again. Now we do addition of these numbers that we've got. So 8 plus 0 is 8, 0, 1 up there, and that's going to be 10 again. So that is going to be our answer. So 12 times 334 is going to be 4008. You can add a comma there if you like, you don't have to. But yeah, that's how we do the long division, the multiplication algorithm. But because these numbers were fairly easy to deal with, what if we had something like, let's say we have 33 times 104. How would we do that? Now we're going to write 104, and then we're going to write 33 just below it, put the multiplication sign, and then we start from the number on the right. So here, 3 times 4 is 12. But now how do we write 12? We shouldn't write the whole thing down there, otherwise we will get a far big number. So what we're going to do is to write the ones place here. And because we've got a 10, we're going to carry it over to this. But this, before multiplication, we do not add this one onto the 0. We still go 3 times 0 is 0. But then like in addition, you can add this one on. So we've got 3 times 0 is 0, plus 1 is 1. Now we've got 3 times 1 is going to be 3, and we can just write it down there. Now we're going to be moving over, so I'm going to write that 0 down there. And now we've got 3 times 4, that's going to be 12. But because we've got a carryover, we're going to put the 1 there, and it's already there from last time. But if it was there from last time and you have a different carryover this time, we do not think about that. We get that out of the way. So basically we rub that out before, and now we've got a 1 again. So these two are very independent. So now we've got 3 times 0 is 0, plus 1 is going to be 3. Sorry, is going to be 1. So that was going to be 3 times 0 is going to be 0, and plus 1 is going to be 1. Now we've got 3 times 1 again, now we've got 3. So as you can see, we've got the same numbers, just shifted once. So you don't even have to do it again, because you already know 3 times this number is going to be giving us that. Now we can go here, and we can add these ones. So we've got 2, 3, 4, 3. So now that is going to be our answer here. So do we kind of get how these can differ? Now, we've got our answers 3, 4, 3, 2. But what if we're dealing with decimal multiplication? How do we deal with that? So it is a little bit different. It is a bit different, but very similar as well. So if we've got, for example, 2.32 times 4.01, how would we do that? Now we write it down like normal multiplication, like the one we just learned, 2.32 times 4.01. Now we just ignore the decimal point for the start. We just completely ignore the decimal point. So now we've got 1 times 2 is 2, 1 times 3 is 3, 1 times 2 is 2, and then we add a 0. And because we're multiplying by 0, all of this is going to be 0. We do not care. But now we're going to move up one more. So we added a 0 before because we were moving up from here, so just once. But now we're going times 100. So this times 100 is going to be giving us a number in this place. So we're going to be adding 2 zeros this time. And we've got 4 times 2 is going to be 8. 4 times 3 is 12. We carry the 1 and we write the 2. And then we've got 4 times 2 is 8. Plus 1 is going to be 9. Okay? And now we add all of this together to get 2, 3, 0, 3, 9. So we've got our answer now, 93032. 93032. But hey, hold up. We completely forgot about the decimal points. Now what? Now, we know that there were 4 decimal numbers. So we've got 4 numbers after the decimal point. So here we're going to have 4 numbers after the decimal point as well. So we're going to put our decimal there, if that makes sense. So if we had a number like 232 and we had a thing like 1 times 2.32, what would we do? We would put the decimal point after 2 numbers. So here we're going to be putting our decimal point here as well. So that is equal to 1.2.32. Okay, similarly over here we've got 4 numbers after the decimal, we've got 4 numbers after the decimal. Hopefully that makes sense. Now we're going to move on to some questions for better understanding. The questions will be in the next video, so make sure to watch that. It will be in the same playlist, which is the year 7 and 8 maths number playlist. Yeah, so happy learning!